But then, in 1967, astronomers here in Cambridge discovered the first pulsar, an object powered by a collapsed dense star, the first hint that such objects really existed. And suddenly, black holes were back on the agenda. Here at Gonville and Caius College, a young Stephen Hawking took up the challenge to take a fresh look at black hole theory. And right from the start, he managed to make waves.
Black holes were thought to be completely black, until I discovered that they glow like hot bodies, with a temperature that is higher, the smaller the black hole. This points to a deep and unexpected connection between black holes and thermodynamics, the science of heat.
The trouble was, how could heat be coming from a black hole? Nothing should be able to escape a black hole. Hawking suggested a new form of radiation, consisting of strange particles that exist in the bizarre world of quantum theory.
Quantum mechanics implies that the whole of space is filled with pairs of virtual particles and antiparticles that are constantly materializing in pairs and then annihilating each other. Now, in the presence of a black hole, one member of a pair may fall into the hole, the other particle may fall after its partner, but it may also escape to infinity, where it appears to be radiation emitted by the black hole.
This mind-boggling concept is now known as Hawking radiation. And with it, Stephen Hawking had solved the problem of how energy can escape from a black hole. The trouble is that in solving one problem, it created another, bigger one, the information paradox.
In Einstein's most famous equation, E equals mc squared, he showed that energy and mass are intertwined. So a black hole losing energy must also be losing mass, albeit very slowly.
The radiation will carry away energy from the black hole. The black hole will lose mass and eventually disappear. This creates a paradox, because the information about what fell into the black hole appears to be lost, but the laws of physics say that information can never be lost.
Information's tricky. It's not things like names and stories that can't be lost. Maggie met up with cosmologist Andrew Ponson to find out what kind of information does cause the paradox.
Information is a critical thing in physics. It's telling us where we are and how we're sitting and what we're made out of. We think of all of that stuff as being information.
So this is the parameters that govern the atoms in the universe?
Yeah, exactly. The idea is that if you know everything about how the universe is today, then you should be able to predict what will happen in the future, or work through the equations backwards and predict what happened in the past. But if you want to be able to do that, then you need this idea of preserving information. Now, the problem is, if you imagine something falling into a black hole, you or me, or maybe just put the whole Earth into a black hole. In fact, I can do that for you right now. Yes. So I take my...
oh, phew, just a piece of paper.
Yeah, no, not the real Earth, just a piece of paper. So I pop it into my black hole over here, for which I'm using a shredder. Now, in principle, if you looked carefully enough inside the black hole, you can imagine you've got some bits and pieces in there.
So we could recreate this and put it back together with a long time and a lot of sellotape.
It would be pretty boring, but you could do it in principle. So the information is still there.
OK, yes.
However, with Hawking radiation, very slowly, a black hole actually reduces its mass. So over time, it gradually shrinks away until it's completely gone. There's no trace of the Earth, no evidence that it ever really existed, let alone what it was made up of.
And you can't retrieve that information in any way?
Exactly. It seems like you wouldn't be able to get at that information at all. So there's no way you could work backwards and work out that the Earth used to exist. It's just gone and lost.
So is there any way to resolve this?
We hope there's a way to resolve it, but right now it's fair to say nobody knows. And people are trying to resolve